Okay, so learning outcome 5. So when light enters a different material, and we usually call whatever material, right, a wave is travelling through the medium. So I'll put in brackets because you'll probably come across that word. Right, so you might see this phrased when light enters a different medium. And what this all comes down to is the idea that it changes speed. This is called refraction. Okay, so that's the name that we give to this effect. If it enters straight on, it goes straight through. So that was the first experiment you did. And if it enters at an angle, it changes direction. And what we're going to do is basically draw the diagram of what we found in the experiment. So can you make sure that your diagrams are nice and big? Yeah, there's rulers out here if you want to borrow. Right, if you make it too small, it makes it very difficult to copy accurately. Okay? So do you agree that's the situation we looked at in the second experiment? And what happened was it changed direction. Now we want to be able to measure how much it changed direction. So to do that, the direction is best measured as an angle. So we add in an extra line. So this doesn't represent the ray, right? It's just a line that we should use for measurement, right? It's called the normal. Right, actually I've not drawn that very well because it doesn't actually match up. Try again. Yeah. Yeah. So it's got to meet the top of the blue bit. It's got to meet where the ray going in strikes the surface. And it's got to be at right angles to the block. So if I put in a wee right angle symbol, you all met that in maths, yeah? So this line I'm going to label is called the normal.
What does that mean, the normal?
So a normal, and I'll write that over to the side as well, a normal is a line at 90 degrees to the surface. That's what it means. In fact, I'm not going to put it there because I'm going to have a ray coming up there. Shh. So now if we go back to tracing what happened to the ray, the block, it changed direction. So what I'm doing is lining up my ruler now along the direction that the ray was going, and then I'm going to spin my ruler so that it's closer to the normal. So the phrase that's usually used to describe what's happening is we say the ray has bent towards the normal. So you have a ray now which is closer to the normal. Other bits that we want to define are the angles involved. So this angle here I'm going to label as a capital I, and this angle here I'm going to label as a capital R. And underneath then I'm going to define what they mean. So angle I is called the angle of incidence. All right, it means the easiest way to remember that is that the angle it goes in. And notice these angles are measured between the ray and the normal, not between the ray and the block. Okay? Okay, so R is the angle of refraction. Okay, so as it leaves, I need to draw in the normal again. So I've got two normals because refraction's occurring twice here. So there's another normal. As it leaves, it speeds up again. So instead of bending towards the normal, it will bend away from it. And the last part, because this is a rectangular block, then it will bend back away to the exact same angle as it entered. Right, but only because it's a rectangular block. So the final direction of that ray will be in the same direction as the very starting ray. Right, this one down here will be in the same direction. Both those rays are in the same direction. At that second surface, I could also call that angle I and that angle R. Okay, because it's all about, in this case, it's all going left to right. Right, and that's a normal as well. Okay, last wee bit. When light enters glass, or any other medium like plastic or water, it bends towards the normal. When it leaves, it bends away from the normal.